So let's see what we can see in here. Now I have to remember to do what I said I'd do. Now see, this thing's got an automatic interlock right here. It's just a little mechanical bar, and when the lid's on there, it keeps it up. But when you take the lid off, it automatically shorts out the B plus right away. Oh, here is an exploded filter cap, a couple of them, 3 of them. So there's our problem. Dear, oh dear, oh dear. Look at that. I'm going to zoom the camera in on this because this is classic. This is classic. So there's that capacitor split in the side, the top's blown off, the top's blowing off that one. That one is all expanded. Something bad had happened in here. And not only will we have to replace all those filter caps, but then we're going to have to look at all the diodes and make sure that the diode hasn't shorted out to cause this to happen. This surprises the heck out of me. But there it is. It's very obvious what's gone wrong here. So now I'm going to get in there and make sure every single cap is shorted out, and before I start sticking my paws in there, because when things blow up like this, you can't count on the fact that the bleeder resistors are still intact, or even that every cap is still intact, although no smoke ever came out of it. But I think I'll tilt this over here so you can see in here. You can see a big long trail of goop that's come out of this filter cap, blown up here and gooped its way all along here. So boy, there's a classic catastrophic failure in the power supply board. I guess I might just as well remove that board. I'm going to have to remove it to replace the caps, and I can inspect everything. I'm going to go in with my screwdriver and see if I can make sure that everything is completely shorted out and discharged. Got the big bubble on the side of this capacitor. That's nasty. That's very nasty. So I'm going to make myself a do-it-yourself shorting bar here. And I'm going to go in, and each one of these little pairs of resistors I think are bleed resistors for each cap. So I'm just going to go across and touch everything. You can see I'm a little jumpy. I do not want to get bit because I was careless. I don't trust anything in here. Just because this high voltage lead is shorted out doesn't mean every one of these capacitors is discharged. Not when we see it in this kind of shape. I'm going to have to check every diode in this thing. And oh, well, that's unfortunate, but I'm glad it's not anything any worse. So I'll unplug the plate transformer here, I hope. Come on. Simple. Right tool for the right There we go, squeeze. So there's the plate transformer disconnected from it. The high voltage is just a feed through from the board right through here. So I will unscrew this high voltage lead from the plate choke. Try to do this without dropping the screw if I can. I think I'll put that screw right back in there. Screw it all the way back in. We won't lose it, misplace it, or put it in the wrong place when we put it back together. All right. So now, here's the other interlock switch here. So it looks like there are 1, 2, 3, 4 screws, one on each corner, that holds this board in here. Here's another little plug, and we don't know what that does. We'll have to find out. My guess is it's a for the metering. Something blew up how many are these? 1, 2, 3, 4, 5, 6, 7, 8. Something blew up 1, 2, 3, 4 of them. How very disconcerting and interesting at the same time. It'd be interesting if it wasn't my radio. That's going to be fun to get to. Oh dear. I may have to take this other, the bottom half off just to be able to get a screwdriver in there. Probably be good to inspect everything anyway. I think I'll... All right. I don't know why I don't want to take the bottom half of this off right now. I just don't. But I'm going to have to eventually anyway. So... such a pain in the ass. Okay. When in doubt, do it the right way. No one can ever say that TenTec skimped on the screws. The screw's been brutalized somehow. Just add crud in the... Oh, there is a God, there is a God. Look at that. Now... Ha 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 ha! Still can't do it. Oh, don't you love it? That's the longest Phillips I've got. That did it. Whoever tightened that screw was serious about it. And well, they should be, because that's the negative side of the high voltage. To ground there, I think. Annoying. Some better glasses. I was going to turn this off till I get this screw out. This is dumb. There we go. Alright, so now where's the screw? Screw in the lock washer. So, there's the board. No damage to the board at all. No overheating, no burn traces, no arc marks, no nothing. Just a lot of very bad capacitors. My, oh my, oh my. All of these capacitors have numbers on the top, and they all say 9811. You can decide what that means, but they're all Mallory capacitors, 400 volts, 220 microfarads. So that's a common value. I think I've got a tub of them up here, I'm pretty sure. $100 microfarad 450, 100 450, got a lot of those. And down here in the bottom, 400 volts, 150 microfarads. I got a lot of those, not 220. So, guess we'll buy some capacitors. Anyway, well, that's an interesting development. Pretty disgusting. I think what I'm going to do is take my handy dandy little felt tip pen and mark on the board where all the negative connections are. See, each one of these black stripes is a negative, so I'll make a little mark on each one so that when I stuff the board after I pull these out, unless underneath the capacitor it's marked somehow on the board, I won't have to try to figure out how to put them back in. But you can see the way they go. Negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. Positive, negative. Okay. So that's all making sense. They're all marked. So I won't have any confusion. I think it's interesting to look at these things. You can see that the top is bubbled here on the top, and it's gotten so hot that it's broken, expanded, and broken the plastic off the side. This one's expanded, broken the plastic off the side. This one is blowing the top off now. This one has lost its top. One of them's got a big bubble in the side of the capacitor. Where is that guy? Well, I can't find it. Oh, here it is. You can see there's a big bubble in the side of the capacitor down here. So it's amazing that some of these are still intact. There's still 3 or 4 that are still physically intact, but they're all going to go. Alright, so I got to remove all of those. Get out the old solder wick. I wish I had a solder sucker to solder wick and unsolder these things. And then I'm going to have to go through and test every single diode, which is going to be an awful lot of fun. Not even going to be easy to do. They're also daisy chaining, positive, negative, positive, negative, positive, negative. Lots of fun. But every one of those has to be checked. And there we go. Well, the bleeder resistors don't look burned. I'll check all of those, of course, and check everything on the board. The question is, what caused this to happen? I certainly hope it wasn't a tube fault. But, yeah, I don't know. I certainly hope it wasn't a tube fault. And got to figure out some way to protect the tube and test it. I never saw it draw any screen current at all. Never was driving it hard enough for it to draw any screen current. I guess I can test it pretty easily for tube for internal shorts and see if any of those exist. I doubt it highly. Just never got any indication at all that the tube was misbehaving in any way. It just seemed to be cooking along swimmingly. This plate connection is just the way I soldered it up, and no changes there. No indication that anything has gotten hot in here anywhere except for these capacitors failing. I have no idea how long this amplifier sat unused before I repaired it and put it back in service, but I even have to look it up to see when this thing was made, as I've forgotten. This is it. But it's got to be 20 or 25 years old, so these capacitors may just have failed for age. And I suppose if one of them fails, they could all follow suit. because it's just a long series string of capacitors. What did I say? We got 8 of them at 400. That's 3,200 working volts, and I forget what the plate voltage is on this thing, but I think it's around 3,000 volts. So it seems like that leaves a lot of room. Anyway, that's all we know for now. Okay, so I'm just removing these things here. I don't have any proper solder wick, so I'm just doing without. But they have very short leads on them, so they come out pretty easily. I gotta buy a proper solder sucker and some real solder wick. I'm trying to use a shield from RG58, but it doesn't have any flux on it, so it doesn't wick very well. Which one doesn't want to come out? Alright, so there's the board with all of the capacitors out. Okay, so I'm just checking the difference between the forward and the back resistance on these diodes. They've got compensating resistors in there, which I think screws the thing up, but we're getting pretty consistent reading. It's down around 521, and the other way it's up over 600. And so that seems to be pretty consistent. If I find anything that's wildly different, then take it out and unsolder it and check it. Okay, so I got this suspect diode out, and I'm going to clean the terminals up on it just a little bit, and we're going to check the front-back ratio of it out of the circuit and see what we discover, because we don't have anything to compare it to, but let's see what we got. Now that we've got well, it's these resistors that make it difficult to measure the front-back ratio. I guess if I unsoldered one end of this resistor here, I wouldn't have to pull the whole diode out. So let me try that. And I'll try to measure the one next to it. Well, what we figured out is that the front-back ratio of this particular diode is considerably different than the one next to it and all the others, but it's still got a front-back ratio. It's still a diode. I think it's just a leaky one. That is not enough to cause the capacitors to blow up. Because this string of diodes is in series, and one of them wasn't there, or it was just shorted out. It would just lower the peak inverse voltage of the diode string, but it would still rectify. It would just like be a piece of wire there instead of a resistor. I don't know. I mean a diode. I think what we'll do is I think we'll find another one of these and replace it, and take an AC voltage source and run it through this diode string without the capacitors and just make sure it's doing what it's supposed to do. And then we'll get the new capacitors and put them in there. I said this wrong. There's 9 of these capacitors instead of 8. So 9 times 400 is 3,600 working volts, and the calculated voltage is around 2,900. So that's it's about 700 volts of ceiling, which is about 25%. So that should be pretty good. I said 8, but there's 9. So that's what we'll do. We'll replace that diode with an equivalent. We'll put a high voltage source on here. I don't know, at least start with a few hundred volts at least. And make sure the diode strings are working the way they should. And then we'll replace the capacitors. We'll test the whole board with increasing voltage. I don't know if we can isolate the whether we'll use this transformer in here. We'll do something outboard with the variac, because I don't want to put screen voltage on this tube and not plate voltage. That's not a good thing to do. The big dog and pony show to disable the screen voltage to the tube. So I think I'll use an outboard plate transformer. Run it up to 1,000 or 2,000 volts with the capacitors in there and on the bench. And if that's okay, I'll put it back in the amplifier and we'll go from there. And see what we get. I guess in the meantime, while I'm waiting, I'm going to have to order these capacitors. While I'm waiting for the parts to arrive, I guess I'll take the bottom of the cabinet off of the amplifier and give everything a visual inspection there. Maybe run some ohmmeter checks, make sure we haven't got some obvious problem. Something that would cause the filter caps to blow up like that. I don't know. I think it's just a cascade. I think probably one filter cap failed and then they just started to go off, pop, 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 like popcorn. That's my guess. But, look into the possible failure modes for this a little bit more.